Welcome to this video. In this video, we're going to look at this equation, and this is kind of an impossible equation because that is why I chose this video. Because usually, what happens is log of AB is equals to log A plus log B, and this is the fundamental rule of logarithms, right? This is how the logarithm is usually defined. But what I want to ask you is this equation even possible? And obviously, this is not true for all values of A and B. This is not an identity, but if we were to solve it, can we solve it? Can we solve it for some values of A and B, or is this like completely unsolvable? Okay, so when I'm saying log, I'm saying log base E here. So I am assuming the natural logarithm here. Okay, so let's begin. So the equation we are given is logarithm of A plus B equals to logarithm of A plus logarithm of B. So, what is the first thing you do when you see an equation involving all logs? Well, you exponentiate the equation with the base it has. So, in this case, the bases are e. So, what we are going to do in the next line is simply exponentiate the both side of the equations. So, e to the power log of a plus b, and I'm not going to write the base from now on. You have to just assume that this is base e now, log a plus log b. So this gives us obviously e to the power log of a plus b should only be a plus b according to the rules of logarithms. And this one on this side, this can be written as e to the power log a multiplied by e to the power log b, correct? And this would give us a into b. So we got a plus b equals to ab. And now let's see if we can solve this equation. Okay, so a plus b equals to ab, and this is not really a bad equation compared to what we started in the first sentence. So a plus b equals to ab can be solved, and keep in mind anything of this form can be solved. Even if there were random coefficients p, q, and r with them, they can still be solved. And by solved, I mean they can be factorized. Let me show you how. Bring everything to one side. ab minus a minus b equals to 0. And now you need to do a middle term factorization here. So add plus 1 to both sides to get ab minus a minus b plus 1 equals to 1. This would give you, if you take a common, a whole into b minus 1, and then minus of b minus 1 equals to 1. And when you take b minus 1 common, you get b minus 1 into a minus 1 equals to 1. And this is the relationship that we have. Now, let's assume that a and b are real. In that case, we can generate infinitely many solutions using the following setup. A minus 1 equals to p, and b minus 1 equals to 1 by p, where we will say that p is a real number and p does not equal 0. Okay. So with this setup, what we can do is a minus 1 is p and b minus 1 is 1 upon p. This would mean that a is basically p plus 1, while b is 1 by p plus 1, which is basically 1 plus p by p. So the pairs a comma b can be represented as p plus 1 comma p plus 1 by p, with p not equals to 0, and this would generate infinitely many solutions. Of course, we need to keep in mind that a is greater than 0, which because we are talking about real numbers, so that would mean that p is greater than minus 1. Also, b is greater than 0, which is already satisfied since p is not equals to 0 and p is greater than minus 1. But if this p is less than 0 and greater than minus 1, then p would be negative. So we must also have p greater than 0. So that is the general. So p greater than minus 1 and p greater than 0, if you combine them, obviously p greater than 0 is going to dominate that. And also a plus b greater than 0. But since a and b are individually now greater than 0, a plus b will also always be greater than 0. So a set of solutions for this equation, and kind of the only set of solutions I would say, is p plus 1 comma p plus 1 by p with p greater than 0. One such solution we can generate a1 comma b1. Let's put p equals to 1 here, and we should get 2 comma 2, right? 1 plus 1 by 1. So 2 comma 2. And let's see if that works. So if you check here, log 4 is indeed equals to log 2 plus log 2. And this is true. So this is the complete set of solutions for this problem. So I hope you like this video. If you want to see more of this content or content related to machine learning, artificial intelligence, and stuff like that, and other mathematics, interesting maths, please subscribe to the channel. And also, it would be very good if you can comment and let me know how do you like this video and if there are any future suggestions. Thank you.